Okay, so after setting up the communication in the channel configuration, so hope you have gone through the previous video. Yeah, we will be now going into how to read a data from the another Modbus TCP slave. Okay, so for that let's do a small configuration. So what we are going to do is, let's open the Schneider software. Let me open EcoStruxure. So we will use this PLC as our Modbus TCP server, and we will use the data from that PLC and read the data from the PLC inside our Allen Bradley system. Okay, so this is real-time communication between two PLCs using Modbus TCP. The same applies for any device, any Modbus TCP based device. Okay, so let me just quickly create the project for you for that. Okay, so inactive, apply, so configuration. So the module we are using there is C24R, and the PLC, I think, yeah, it's the PLC we are using 0.18. So let's configure that Ethernet IP, sorry, in Ethernet 1. So choice continue. So 192.168.0.18. So now we have to enable a few things. We need to enable the Modbus server auto discovery. So we can enable basically everything here, it doesn't matter. So I'm just enabling everything on the, this is on the server side, okay, this is on the slave side. So let's apply it quickly. So let's go to programming, and what we are going to do now effectively is, we are going to set up a few move instructions so that we will be able to see what data is getting moved from where. Okay, so let's put a operational block. So in the operational block, let's say percentage MW0 colon equal to percentage MW, let's say 10 for example. So what happens is, whatever value I write in MW10 will be written into MW0. Okay, so let's say I want to add one more device. Let's say I want to add 4 registers like this. Let's create 4 more. So I will show you how to read one value, and I will also show you how to read multiple values. So yes, we can just branch it out here, should not be a problem. Yeah, okay, so now let's give the connection. So percentage MW1 semicolon equal to percentage MW11. So again, whatever value I give in 11 will be written into MW1. Then percentage MW2 colon equal to percentage MW12. Again, 12 will be written into MW2, and last percentage MW3 colon equal to percentage MW13. So same thing. So we are basically doing the same thing here. We are not doing much difference. Okay, it's all the same thing. You can see MW10 is going to MW0, 11 is going to 1, and 12 is going to 2, and 13 is going to 3. So all are integer data. These are going to be integer data. Okay, let me download this. And let me, so let me quickly log in. So it's logged in. So let's write PC2 controller, download. Yes, it's downloading. Downloaded. So we have to make sure in this PLC some things have to be enabled, or otherwise, you will not be able to download again. But yeah, now it's okay. So let's download it now. So let's start the controller. So now here, let's go to our programming, and you can see the data is all now 0, right? All the values are now 0, right? So now what we have to do is, let's minimize this and let's go to our PLC. Okay, so how do we read and write value, or how do we read data from the Modbus slave? So for that, we have only one instruction in Allen Bradley, that is called as the message instruction. So the message instruction is used for both Modbus TCP and RS485. Okay, Modbus TCP and 485. Based on the settings, it just works. Okay, so let's insert that instruction first. So let's add a new rung, and let's find the message instruction. So I'll just find it, or I can just put any block. Okay, let's say I put a timer block and change it to MSG. That's it. Okay, I just change it to MSG. So now you can see here we need a message file name. So what data type it will support? So normally we have output, input, status, binary, timer, counter, control, integer, float, but you can see it is not having a message data type. So what we have to do is we have to create the message data type first, or the data file first. So we have to right click here on the data files, right click, new, and here you have the option file number 9. Let's keep it at file number 9. The type, there is an option called as message. Okay, so let it be like that. So let's create 10 elements so that it will be useful for us. Not 40, I want 10. Okay, and let's say I want to give okay. So I'm creating a data type data file called as message, which will be giving the addresses to this message file. Similarly, we need one more data file that is called as the routing information. So that is for setting up the IP address for the slave and everything. So let's create a file number 10, and you can see there's a data file called as routing information. So let's click on routing information. Let's give 10 again for that and give okay. Okay, now you can see the message MG9 and R10. So if you open MG9, you can see there are 10 MG9 files created. Similarly, when you open R10, you can see that there are 10 routing information file created. So the routing information will contain required data for all the communication parameters. So let's give the first address. So let's give MG9.9:0 for the message file. Okay. Now let's go into the setup screen. So in the setup screen, it is asking what is the channel. So we will do it step by step. So I will go into and I will say integrated Modbus TCP. Okay. So now once that is set, you can see all the the complete requirement has changed. Now the Modbus command. So the Modbus command has multiple options. You can see there is multiple options. These are called as Modbus function codes. We call them as Modbus function codes. So you can see there we have you can say let me explain. Okay, you have the let me quickly open snipping tool so I can show you a few things. Yeah, okay, so I'm not able to get it as a snip. So let's yeah, it's okay, no problem. What we will do is we will use it directly like this. So for example, if you see here, you can see read status coil. So read coil status, that means this is to read the output coils. Okay, the output coils in a program like O:0.0.0/0. Similarly, this is to read the input status. Input status means to directly read contact data. Okay, contact data. Then we have the holding register. So holding register means normally the holding registers are read or write data, where you can read as well as write into the registers. Normally we use this data register for everything because this is more easy to use. Similarly, there is a input register as well. So input register means, so this is a read only value that is on the server. So you cannot change the value on this registers, but you can you cannot change the value, but you can read the data from the server. Then we have write single coil. So writing to a single coil output, write a single register, holding register, write multiple coils. Okay, so we have multiple options. So you can write a single coil or a multiple coil. Similarly, you can write a single register or multiple registers. So for each of this there are different Modbus function codes. For each of this there is Modbus function codes. So you can see the holding registers or the read or write registers normally starts with the address 4. Okay, 4xxxx. So it's normally a 6-digit number. Okay, similarly, if you are going for a input register, input holding register, then the Modbus address will start at 3xxxx. Okay, so for us we need to read a holding register because we are going to read integer data, and these holding registers are integer data types. The coil and contacts are bit level data types. So let me give a small short example for the Schneider. In Schneider, what happens is, so we gave %MW0, right? Then we have %MW1. Okay, so this is in Schneider, this takes the address 400,001, 400,001, because in Modbus the address will never start from 0, it always starts from 1. So MW1 will be 400,002. So it goes on. So percentage MW9 will be 4000010. Okay. So then we have created MW10 and all, right. So if you are going to read that as well, so MW10 will be 400, sorry, not okay, 40010, 40011. It goes on like this. Okay, so it will be like 1 plus 1 from the actual address for the Schneider. So this is a default value for Schneider. Okay, so let's try to read those data. So let's try to read one data. So it's asking for a data table address. Okay, the data table address will be I will give I want where it is asking where to read this data and store, where to read the data. So to where to store the data. So for example, reading from a particular address and where to store it. So let's say I want to store this in N7:0. Okay, N7:0. Let's say N7:0, and the size in elements going to be 1. So because we are going to read one register, and you can see the MB data address 1, which will be equal to 40001. 40001 or 40001 are same actually. So that is the extended Modbus address. This is the short address. Okay, both will work. Both will work for us. Okay, so 40001 and 4000001 is also same. So in a 5-digit addressing, the number next to the prominent number from the left. Okay, so the second number from the left can be neglected if it is 0. So that's why it's showing. So this address can be either 40001 or 4001. 40002. It can go up to 40010. So then 40011. It can go like this. Okay. So this is the extended address and this is the normal address. Okay. So now I want only one data. So it is asking for a routing information file address. So the routing file address is this R10. So we have to give RI10:0. Okay, and we have to make this unit identifier as 1. Unique identifier means this is the Modbus message instruction address. So we are going to use this as 1. If we are using another address, we will use that as 2. So let's say I want to enter the IP address. I can give here 192.168.0.18. So this is the address from the slave PLC, the server PLC. Okay, so 192.168.0.18 is the IP address of the PLC. You can see 192.168.0.18 is the IP address of the PLC from which we are going to read the data. Okay, and let's give, yeah, that's it. So now we have done the configuration here and give, just close this, this is enough, and do a compile. So there is no errors. So then we need one more thing. We need this instruction to continuously run. We need this instruction to be continuously run so it can refresh data continuously. So we will use the status register. Okay, we will use the status register S2. Okay, so let's put an NO contact here. Let's say S2:4/12. Okay, it's a time base. It is a time base, so 12 should be enough. So let's compile it and let's download it. So let's save it as maybe Modbus TCP read. Okay, so save it. So now I'm downloading. So the PLC is now downloaded, and we need to make sure that the communication, it's saying the communication configuration is different. So it is asking whether to apply the new communication configuration. Apply. We should go online. So and we need to do one more thing. You have to understand that whenever you are changing any communication setting in the Allen Bradley PLC, okay, any communication setting in the Allen Bradley PLC, you have to reboot the drive. We have to reboot or power cycle the drive for it to make it work. So it's only needed for the first time. So what I'm going to do, I'm going to just reboot the device and come back. Give me a second. So this is my PLC here. So I have just power cycled my drive. I have just power cycled my drive. Okay, so now it should again come to online. So let's go online. So yes, it will take a second. Yes, now it's continuously running. So let's put both of these side by side so that we can see what is happening. And let's say I want to show, okay, so programming. So here one second. Okay, so no issues. So it is continuously running. There is no data showing up there, but all the data will be reflected in the N7 register. So as of now we are only using N7:0. So because we are only trying to get one data. So whatever now we will enter data into MW10, which will reflect into the Allen Bradley PLC. So let's go here and let's give a value in MW10. So MW10, whatever value you give on MW10 will be written into MW0. So the time base I'm using is a 500 millisecond time base. So let's say give 500. So you can see it immediately went to 500. So if you increase the time base, the data acquiring speed is also very high. So let's say give 1. So it will immediately change to 1. Let's say I give 1000, so 7500. So you can give up to 32767. You can give up to 32767. If the value exceeds 32767, then that it will the system will fault because of the limitation in the integer data type. So we are now able to read data from a Schneider PLC into an Allen Bradley PLC via Modbus TCP. So this is reading a single register. So for example, I am just writing this in MW10, but I am reading it in MW0. But you can see here, if I go here, for example, in MW11, and if I am entering something, it is reflecting in MW1, but it is not showing up here because we did not configure. So now we are going to see how to configure multiple data registers. So for that, let's make it full screen. Go offline here. So it's very simple. We just need to do one small setup. Go to the setup screen and you define here how many data address you want to read continuous. So for example, if you are going to read, so the catch here is, for example, if you are going to read 10 addresses continuously, then it's not a problem. But you want to read, like there are 10 address, okay, 1, 2, so 1, 2, 3, 4, 5, 6, 7, 8. You want the first 2 address and you want only the last 3 address. You don't want these 3 addresses. Then you have to create it as 2 different message instructions. Or what you can do, you can read all these 8 instructions, 8 registers, and neglect these 3 instructions. Okay, it's up to you how to use that, but it's better to read it in a go so that the communication happens in a single instruction itself. It's instead of splitting the same instruction into 5 6 instructions, just put it into a single instruction, so it will be easy for us to finish the communication. So let's do it like that now. So I'm setting up, I want the address as 4 here. Okay, I want the address as 4. So the MB address is, starting address is 1, but the element I want to read is 4. I want to read 4 elements continuously. 4 elements continuously. Okay. So what happens is it will store from N7:0 to N7:3. So close this, compile it. Now if you go into N7, you can see this got created for 4 sizes. Okay. So now let's quickly download it and see whether it is. Yes. So now you can see it took the address, the data immediately as 56 as we entered last. So let's give another value here. Let's say I want to give 865. 865 got read instantaneously. So I want to give a value in MW13. So let's say 7845. So that value also got read instantaneously. So this is how we read data, okay, from a Modbus TCP server, from a Modbus TCP server or a slave into a Modbus TCP master. So in the next video we will see how to write values into the register. So now we only use the read command. We will also now see how to give the write command into the system. Okay. See you on the next video. Thank you.